Hello everyone, welcome to PYQs. This is IAS 2014 question from Dynamics section. So the question says the particle is acted on by a force parallel to y-axis. Suppose this is x-axis, this is y-axis. So a particle is here, a force is applied in parallel to y-axis. Now this is x, this is y. I have applied force on parallel to y-axis whose acceleration is given by this. So acceleration is given by y double dot is given by mu upon y square, and in bracket it is written always towards the x-axis. So this acceleration is always opposite to the force. This is x-axis, so towards x-axis it means I need to take minus. So this is the equation of given. So first thing given is this. In y direction acceleration is given by this, and now at second thing is y equals to a पे it is projected parallel to x-axis. Now y equals to a पे जो x-axis की velocity है, so y equals to 0 होगा, y is equals to a पे, और x equals to x dot equals to दिया हुआ है, y dot कुछ नहीं दिया हुआ. So this is given, it is projected. Now find the parametric equation. We need to find out the parametric equation. These two things are given. Now we know that parametric equation will be function of the path. Parametric equation of path we need to find. You know the path will be something like function of x and y. For finding x and y function, we need to find dy by dx. Or now to find dy by dx, we can find out dy by dt and dx by dt. So we know that if we find y dot and if we find x dot, and then we can represent this in parametric equation. So how we'll do it? So here I'll try to solve it. You know y double dot that is acceleration is given by minus mu y square. So if we integrate, first of all multiply with 2y dot from in both sides, so that is equals to this, and then minus mu upon y square and into 2y dot. Now if you integrate both sides, what I'll get? Here I'll get y square, and here I'll get 2 mu y and plus from c1. Okay, so y dot, this is what we'll get. Now you know at y equals to a, it is projected in x direction, so initial velocity y dot is equals to 0. So putting here, I'll get c1 equals to minus 2 mu by a. So from here I can get y dot is equals to 2 mu. If I'll take common, I'll get 1 minus y dot square, 1 upon a. So if you simplify this, I'll get y equals to, in plus minus, but you know velocity is decreasing because acceleration is always in towards the x-axis. So this will be negative sign taken and 2 mu upon a, and here I'll write a minus mu by y. So this, after solving and applying condition, we have this equation. So this is equation number 1. Now what we can do, we now go for x direction. What x direction is given? There is no force in x direction, no acceleration in x direction, so x double dot is equals to 0. So if we integrate this, I'll get x dot equals to c1. Now using this second condition, that is at y equals to a, x dot equals to root of 2 mu a. So since this is given, so if you put y equals to 0, there is no y term, x dot equals to this, so it implies c1 is equals to root 2 mu a. Okay, so it implies x dot is equals to root 2 mu a. Okay, so this will be the equation second. Now as I have told you earlier, to find dy by dx, what I can do? I can do y dot, that is y upon x dot. So now if divide these two things, I'll get minus a minus y upon y. Now you got this. Now to integrate this, what we can try, this is you can try variable separable method. So this is dx, take it negative that side, and this is y, a minus y dy. Now to integrate this, let y equals to something a cos square theta. So you got it. Now what will get dy equals to? Dy will be equals to 2a and then minus, this will be cos theta into sin theta d theta. So put this in this equation, I'll get dx equals to integration. Here it will be a cos square theta, a will be cancelled, cos theta will be cancelled. So I'll get cos theta, and here I'll get sin square theta. That will be cos theta. Let me write cos theta upon sin theta and multiply with 2a cos theta sin theta d theta. So integrate it, and some constant c1. So that will be equals to x. Let me scroll this down. So I have taken y equals to this a cos square theta. Now what I'll get x equals to, if we cancel this cos theta to this, and I'll get, take a outside, I'll get 2 cos square theta d theta plus c1. So now to integrate this, you know, it can be written as a 2 cos square theta minus 1, that is 1 plus cos 2 theta. It can be written as 1 plus cos 2 theta d theta plus c1. Now to integrate this, x equals to, I'll get a, that is theta, and plus cos theta integration sin 2 theta and 2 theta by 2. So that is plus c1. So this is what we'll get about x. Now again, if we put the condition, that is at x equals to 0, then at x equals to 0, y is equals to a. So from this is third equation, you can see at y equals to a, x is equals to 0, then I'll get cos theta, cos square theta is equals to, cos square theta is equals to 1. It implies theta is equals to 0. So now if x equals to 0 and y equals to a, then theta is equals to 0. So from here I'll put this theta is equals to 0 here, and x equals to 0, I'll get c1 is equals to 0. So from this I'll get x equals to a theta plus sin 2 theta by 2, and y equals to, I've already got that, cos square theta. So these are the two parametric equations which we need to find out here. So that is all in this lecture from my side. Thank you.